Imagine for a moment gathering every single star in the cosmos. Think of the sheer number, the unimaginable brilliance, the collective light of countless suns. Every planet, from the familiar worlds of our solar system to the exotic exoplanets orbiting distant stars, and every last dust grain, those tiny particles scattered across vast interstellar spaces, the building blocks of future worlds. Even with all of that, you'd still be missing almost all of the universe. An astonishing amount remains unaccounted for. The matter we know, everything we see from the smallest atom to the largest galaxy, all the visible components of the cosmos, makes up just a tiny fraction of the total mass, a mere sliver of the cosmic pie. The rest is invisible, a hidden realm of existence, detectable only by its gravity, its influence subtly shaping the universe around us. This mystery began in the 1930s, a time of groundbreaking discoveries and nascent understanding of the cosmos, when Fritz Zwicky, a brilliant but often overlooked astronomer, studied the Coma Cluster, a vast collection of galaxies bound together by gravity, and found galaxies moving so fast, whirling around the cluster's center at incredible speeds, that visible matter alone couldn't hold them together. There simply wasn't enough mass to generate the gravity needed to keep the cluster from flying apart. He proposed the existence of dark matter, a revolutionary idea at the time, an unseen mass, permeating the cluster and providing the missing gravitational glue. For decades this idea was largely ignored, relegated to the fringes of astronomical thought, until Vera Rubin and Kent Ford in the 1970s took up the challenge, observed that stars at the edges of galaxies, far from the central bulge, moved just as fast as those near the center, defying the laws of Newtonian gravity. This defied expectations, challenging the very foundations of our understanding of galactic dynamics, and pointed to a massive, invisible halo surrounding each galaxy, a vast reservoir of unseen matter. The only explanation? The inescapable conclusion. Galaxies are embedded in vast halos of dark matter, invisible structures that dwarf the visible components, providing the extra gravity needed to keep them intact, preventing them from disintegrating into the vastness of space. The universe, it turns out, is far stranger and more mysterious than we ever imagined, is dominated by something we cannot see, a hidden force shaping the cosmos on a grand scale. The beautiful spirals of stars, the luminous galaxies that dot the night sky, are just the tip of a much larger invisible iceberg, a hidden mass that makes up the vast majority of the universe. Our cosmic stage is ruled by an unseen actor, a silent force that orchestrates the movements of galaxies, whose gravity shapes everything from the formation of galaxies to the large-scale structure of the cosmos. The universe isn't just a little strange, it's profoundly mysterious. It's fundamentally different from how it appears, a cosmic illusion where the visible is only a small part of the whole. Most of what's out there, the vast majority of the universe's mass and energy, is hidden in plain sight, a cosmic secret waiting to be unraveled. So what is dark matter? The truth is, we don't know. It's not dark like soot, it's transparent, invisible, and doesn't interact with light at all. It passes through us every moment, yet we feel nothing. Dark matter is the hidden engine driving galaxies, its existence revealed only by gravity. It must be cold and slow-moving so it can clump together and form cosmic structures. It's also incredibly stable, surviving since the Big Bang. This makes dark matter one of science's greatest puzzles. A glaring gap in our standard model of physics. Finding it would revolutionize our understanding of the universe. It's like discovering a new color, revealing a hidden layer of reality. The search for dark matter is a quest to complete our picture of the cosmos. Gravity, the universal sculptor, builds the universe, shaping the cosmos on an unimaginable scale. It's the force that draws everything together, from the smallest particles to the largest structures. But ordinary matter alone isn't enough to explain the universe we observe. There's a missing piece to the puzzle, a hidden ingredient that plays a crucial role in cosmic construction. As ordinary matter clumps together under gravity's influence, it heats up intensely, creating pressure that resists further collapse. This heat acts as a barrier, preventing the formation of stars and galaxies. It's like trying to build a sandcastle with dry sand. The grains just won't stick together. They lack the necessary cohesion to form a stable structure. Dark matter, however, is a different beast altogether. It doesn't interact with light, making it invisible to our telescopes, and it doesn't create pressure like ordinary matter. It only feels gravity, responding solely to its pull. This unique property allows it to clump together without resistance. In the early universe, when everything was much denser, dark matter collapsed into vast, invisible halos and filaments, forming the initial seeds of cosmic structure. This dark matter network acted as scaffolding for everything else that would eventually form. It provided the gravitational framework upon which galaxies and stars could assemble. These structures became deep gravity wells, immense reservoirs of gravitational potential, pulling in ordinary matter like water flowing into hidden valleys, drawn inexorably towards the lowest point. Hydrogen and helium, the raw materials of stars, pooled in these wells, accumulating in vast quantities. As the gas reached critical densities, it began to cool and ignite, giving birth to the first stars and galaxies. The galaxies we see, with their dazzling displays of light, are just luminous decorations on a much larger, invisible framework, a cosmic skeleton that dictates their distribution and behavior. Each galaxy sits at the heart of a massive dark matter halo, a vast, unseen sphere of influence 10 times larger and more massive than the visible stars contained within. This halo is the true gravitational anchor of the galaxy. These halos connect through immense filaments of dark matter, vast bridges spanning intergalactic distances, forming the cosmic web, the largest structure in the known universe. Galaxies are like bright cities, glittering islands of light in the vast cosmic ocean, strung along invisible highways of dark matter, pathways that guide their movements and interactions. Their locations and relationships are dictated by this dark scaffolding, the underlying framework that shapes the universe. Our view of the universe, limited by our ability to detect light, is fundamentally shaped by what we cannot see. The real architecture of the cosmos, the grand design of the universe, is hidden in darkness, waiting to be unveiled. Dark matter, the unseen and enigmatic substance, is the silent architect of everything we know, the master builder of the cosmos. How do we know this invisible scaffolding is real? Cosmic simulations. Scientists use supercomputers to model the universe, adding ordinary matter, and dark energy, then let it evolve. When dark matter is included, the simulated universe forms galaxies, clusters, and cosmic webs, just like what we observe. The simulations even reproduce the flat rotation curve seen by Vera Rubin. Without dark matter, the universe in the simulation is sparse and structureless, nothing like ours. The contrast is striking. Dark matter is essential for building a universe like ours. It's not just a fix for odd observations, it's the master architect. Without it, cosmic evolution fails. Simulations show that visible matter alone can't create the universe we see. Dark matter is the key ingredient in the cosmic recipe. To understand how it all began, we go back to the Big Bang. The early universe was a hot, nearly uniform soup of particles and energy, but it wasn't perfectly smooth. Tiny quantum fluctuations created minuscule density variations. These were the seeds of all future structure, visible today as ripples in the cosmic microwave background. Ordinary matter was trapped by radiation, unable to collapse. Dark matter, unaffected by light, began clumping immediately, amplifying those tiny fluctuations. Over millions of years, these clumps grew into the first large-scale structures, gravitational basins that deepened over time. Only after the universe cooled could ordinary matter fall into these dark matter wells. The stage was set for the birth of the visible universe. Dark matter laid the foundations for everything that followed. Once ordinary matter could fall into dark matter's gravity, Wells' galaxy formation took off. Small dark matter halos attracted more matter, growing larger and merging over time. Inside these halos, gas cooled and contracted and ignited into the first stars. Early galaxies were small and irregular, but constant mergers built up larger structures. Each merger brought new gas and triggered star formation, growing galaxies like our Milky Way. The universe is a dynamic ecosystem where galaxies grow by consuming their neighbors. All of this is orchestrated by the invisible hand of dark matter. The cosmic story is one of growth, collision, and transformation. Galactic collisions are among the universe's most spectacular and awe-inspiring events. These cosmic encounters reshape galaxies on a grand scale, triggering bursts of star formation and creating stunning visual displays that captivate astronomers and stargazers alike. Galaxies merge completely, their stars, gas, and dust intermingling over millions or even billions of years. This process transforms the shapes of the galaxies, often resulting in the formation of a single, larger galaxy with a more complex structure. This merging isn't just because of their stars, which, while visually stunning, only represent a fraction of the total mass involved. The true drivers of these galactic mergers lie hidden in the unseen depths of space. It's due to their massive dark matter halos, vast reservoirs of invisible matter that surround and permeate galaxies. These halos extend far beyond the visible boundaries of the galaxies themselves. These halos act as gravitational glue, exerting a powerful attractive force that draws galaxies together. Without them, galactic mergers would be far less frequent and far less dramatic. This gravitational pull is what slows galaxies down as they approach each other, ensuring they merge rather than simply passing by in the vastness of space. It's a cosmic dance orchestrated by an invisible hand. The bullet cluster is a dramatic and compelling example of this phenomenon in action. It provides a unique window into the behavior of dark matter during a high-speed collision. In this system, two galaxy clusters collided at tremendous speed, creating a shockwave of epic proportions. The aftermath of this collision reveals the distinct separation of ordinary matter and dark matter, and most of the mass, traced by gravitational lensing, a phenomenon where gravity bends light, is found in a different location than the hot gas. This provides crucial evidence for the existence and properties of dark matter. The hot gas, which interacts and slows down during the collision, lags behind, while most of the mass remained with the galaxies, not the hot gas. This separation provides strong evidence that dark matter is real and collisionless, meaning it doesn't interact with itself or ordinary matter in the same way that gas does. Instead, it moves through the chaos of the collision relatively unaffected, continuing on its trajectory as if nothing had happened. The bullet cluster visually confirms what scientists have long suspected, that most of the universe's mass is invisible, hidden from our direct view, but detectable through its gravitational effects. Dark matter halos act independently of ordinary matter, influencing the motion of galaxies and shaping the large-scale structure of the cosmos. This independent behavior is compelling evidence that dark matter is a physical substance, not just a mathematical construct or a flaw in our understanding of gravity. It's the glue that holds the cosmos together, forming the scaffolding upon which galaxies and galaxy clusters are built. It maintains its influence even during violent collisions, ensuring that structures don't simply disintegrate in the face of cosmic chaos. Without dark matter, the universe would be a vastly different place. Galaxies would simply drift apart, unable to overcome the expansion of the universe and form the intricate structures we observe today. The universe's grandest structures, from individual galaxies to massive galaxy clusters and the vast cosmic web, owe their existence to this invisible force, this hidden architecture of dark matter that shapes the cosmos on the largest scales. Dark matter is the silent partner, the unseen hand that guides the evolution of the universe. It's the choreographer in every cosmic dance, orchestrating the movements of galaxies and shaping the destiny of the cosmos. The evidence for dark matter is overwhelming, but what is it? The leading candidates are WIMPs, weakly interacting massive particles, and axions, both hypothetical and elusive. WIMPs would be massive, interacting only through gravity and the weak force making them hard to detect. Experiments deep underground search for rare WIMP interactions, but so far no definitive signal. Axions are ultra-light particles possibly forming a cold sea throughout the universe. Other ideas include primordial black holes or even new theories of gravity, but these struggle to explain all observations. The particle hypothesis remains the favorite, and the search continues in labs, underground, and at particle colliders. Solving this mystery could revolutionize physics. The hunt for dark matter is one of science's greatest adventures. The quest to understand dark matter is a journey to the edge of knowledge. We now know that everything we see is just 15% of what's out there. Solving the dark matter mystery will trigger a revolution in physics, revealing new particles or even new laws. The story of dark matter is a cosmic detective tale with clues scattered across billions of years and light years. The answer will reshape our understanding of the universe and our place within it. The universe is whispering its secrets, hidden in the spin of galaxies and the bending of starlight. The greatest discoveries reveal how much we still have to learn. Follow Science Deeps for more mind-blowing science facts.